insights and models that come from that. But again, a key aspect, if there's one thing that I want to take away is it starts with your data. Like that's kind of the foundation of how we think about machine learning. And then there's a set of ML algorithms, et cetera, that build from that. So let's take a scenario here, right? Let's take, in this case, it's what we call a binary classifier. And this can be data points. Either it's we want to predict whether a customer is fraudulent or not, or we may want to, say, classify if somebody's an adult or a child based on other data points. In this case, each data point is defined by a set of features like X1 and X2. And let's think about how would we easily classify them. When you visually look at the data, you can easily see there's a well-defined stratification between blue classes and orange classes. But how do we enable a computer to learn that? Right? How do we enable a computer to look at the data and automatically detect the next data point you provide gets classified into blue and orange? And really, what we're trying to do is enable the computer to learn these weights. So if you think about a data point defined as two features, X1 and X2, and we want the computer to learn these weights, W1 and W2, and understand, based on these weights, hey, which class does this fall under over a certain threshold, right? And it's really what we're trying to do here. And you can imagine there's some kinds of data where these features go from, whether, like, let's say you want fraudulent customers, these X1 and X2 can be everything from customer demographics to their past sales history to what kind of products, your sales channel. All of these are X1, X2 to Xn. And what we need to understand if you want, say, we want to predict the customer is fraudulent or not, is understand those weights to apply on those features. Does that make sense? And that's really what machine learning is to understand these weights on this data. And it can be anything from sales transactions in your ERP and CRM system, or it can be images that we want to detect whether a part's broken or not, or it can be even like understanding is a customer sentiment about my product, is that positive or negative? Right? It's all about these features of X1 and X2 and understanding weights to be applied on that. One of the technologies we use is neural networks. And if you really think about neural networks, it's really all about understanding. It's a very gross simplification of the human brain, where you can imagine neurons, like two neurons are connected to each other. And the connection between them, the weight of the connection really depends on whether, as you pass data through, whether it becomes positive or negative from the end result. And let me give you an example of that. If you can switch to my demo machine. So in this case, what we have here is a simple neural network. If you go to playground.tensorflow.org, it kind of walks you through a little bit more. But let's say we have two different neural networks. We have a neural network that has a few set of one hidden layer, and we're trying to detect, hey, is it an orange data point or a blue data point? And basically what it does is that as the data flows through the neural network, it's going to learn from that over time, and after some time, it's going to be easily classified into orange or blue dots. So if you run it real quickly, you can imagine that, as you can see, the losses slowly start coming down. That means it's getting more and more accurate over time. And you can imagine by the time it hits 50 dots, for the most part, it's really done learning, and it's no use iterating anymore. Now let's see if we introduce some noise into this, meaning that it's not really that cut and dry, and there's some blue dots interspersed with orange dots, and we run it again. And you can imagine here, it's going to take a little bit longer to come back to predict the right point. And what I mean by that is it's really about sending this data through the neural network over time, and as you keep iterating, the network understands these weights, W1s and W2s, for your data. And then it's going to start, and then basically now that you send a new data point that's untested, it's going to be easily predicted. Back to slides. So this example applies to images, to structured data. In this case, let's say we have a lot of images that we've done. We've trained these data sets on detecting cats, dogs, whether it's cars, apples, well, anything you expect from an image, right? And we've done lots of examples for each label, cat, and we've trained the network to understand these weights for each type of label. And then what we would normally do is send a new image through, and then we want the neural network to detect whether it's a cat or a dog. And similarly, as I mentioned, as the data flows through the layers, you can imagine certain neurons get fired based on the characteristics of the image, and the end result is it's either a cat or a dog. Right? And it's really, the way to think about it is we get raw pixels coming in, and as we go through the layers, more and more the picture gets coarser and coarser, and we start understanding parts of the image. And finally, we know, hey, this composition of this picture looks like a cat or a dog. And that's really what we mean by deep learning. As you can imagine, this applies to images. You can imagine the same thing applying to your data in your ERP systems or CRM systems, whether to speech, language, et cetera. But it's a gross simplification that the same format applies to a lot of different types of data. Now that we've trained the model, doesn't mean the system is ready to go. There's actually an overall life cycle of your data you want to be thinking about, right? You can imagine the first thing you do is you take data from your past years, and you cleanse the data. You've done a lot of data preparation to remove out a lot of the outliers, and you have a well-defined data set, and you basically train a model and evaluate the model against your test data set. And now you feel, you know what, this model is giving me pretty decent results. You put it in production. And then guess what happens? And that deployment is another aspect, right? You're training and testing on a certain data set. You move into production. Most probably, you're going to try to, if you're going to change an existing process, you will do things like A/B testing, where certain set of your processes go through this new model, and the rest of your data goes through that. You will evaluate your results and before you turn the full knob to 100% production. And then you're going to get new data, right? For example, let's say you tested your data on 2016. You run it for the first 2 months of 2017, and now you're in Q2 of 2017, and you want to update the model to all the activity that's happened in Q1. You got to take the data back in, feed that back into the model, you get an updated model, push that back into production, and this becomes a never-ending cycle, right? Again, the takeaway is, even though in some ways, a lot of people get excited about ML, they think about the model, but one takeaway I want to get you guys is 90% of the work is in your data cleansing, data preparation, getting the data ready for machine learning, right? It's only 10% of the work we're doing this fancy machine learning, like TensorFlow graphs. A lot of the work is just raw data cleansing, data prep, to getting the data ready for training or prediction or testing. And this goes back to the thing is, like, if you think about ML as a rocket engine, it's all about the data. I think it's funny. I know people are thinking I should be talking a lot about all these fancy models. I will be talking about the fancy models and all the amazing things we do with that. But I really want to leave with the fact that it all starts with your data. Because unless we have the right data, we're not going to get all these results. One of the reasons why Google does such a good job in machine learning is we have a lot of data. And so we are able to cleanse that. A lot of the work that the engineering team does is all about cleansing, driving training data sets that then feed into our ML models. So in some ways, the infrastructure is a key aspect. The model, the data is a key aspect. The algorithms themselves are open source, right? That's the reason why we open source TensorFlow. They really think about it as deep learning, neural networks, random forests. These papers have been published decades wide. They're all public. There's tons of open source frameworks out there. It's really about the infrastructure and the data that's a unique differentiator. So every tech article these days, you can imagine there's a lot of hype about machine learning, but how much of the hype is real versus not real? One way to think about it is think about raw compute that flows into the infrastructure, right? As you can imagine, CPU growth of pure CPU growth is flat or steadily increasing, but there's a huge explosion of GPU growth. And this is coming from NVIDIA. And the reason why, and one of the things that you'll take key takeaways from the slide is starting in 2015, there's been an explosion of GPUs and of GPU growth. A lot of that is driven by machine learning. Because people are now using GPUs for machine learning, both training and from a prediction side. And they really need a lot of compute cycles to drive that. If you can imagine, and the other aspect that we'll talk a little bit more at I/O coming up is we'll talk about how within Google we've been investing a lot on special purpose hardware for this case, because we're realizing this explosion of compute cycles needed for machine learning, and we've slowly started introducing things like tensor processing units, primarily focused on how we can drive these compute cycles in a better price performance manner for machine learning. Within Google, we've invested significant amount of dollars and resources really thinking about ML. You can imagine there's a very close correlation between the growth of GPUs and deep learning usage at Google. Because we're really seeing a lot of usage of Google across a broad set of different applications. And we'll talk a little bit about some of those applications in the next slide. You can think about, we see things all the way from things around how we do search. We'll show some examples a little bit later. We'll show you things about how we think about image and machine perception, really image and video understanding. We drive things around Google search. We look at things around YouTube. We look at things around structured data, really thinking about recommendations, ad monetization, lots and lots of different examples, all of them driven by ML. Right? And I think more and more, I don't think you'll see a Google product out there that doesn't have some level of ML to drive the user experience. Most of it will be invisible to the end user, but it just enables new experiences. Right? And that's another aspect, think about it, is that it doesn't need that ML needs to be upfront to the end user, but it just kind of streamlines the user experience behind the scenes. For example, in Google Photos, ML is not any people that if you're a user of Google Photos, you don't really know you're using ML. But when you say, I want to search for beaches, and we find photos of beaches, that is machine learning, because machine learning goes and classifies all these images, whether there's a beach in there, or it's a photo of your niece, and enables you to enable that new search experience that was not possible before. How does Google Cloud help you? There are two ways when we think about that. One is we're really thinking about providing you an open source framework that's based on TensorFlow. And TensorFlow is something that within Google we use extensively for a lot of the different frameworks inside Google. And it's open source. It's the #1 machine learning framework on GitHub. If you go down there, you can see we contribute significantly to TensorFlow. We have an open source community also contributing to TensorFlow. You can use it anywhere. You don't necessarily need to use it on Google Cloud. You can use it on-premise. We also enable TensorFlow to run on device, meaning that if you have an Android or iOS platforms, you can now run TensorFlow models on your device. But if you want to provide a managed experience for your training, for your prediction, we have Cloud Machine Learning Engine that went GA in March. That gives you a managed experience that handles all your infrastructure needs around auto-scaling, thinking about how we provision hardware, whether it's CPU, GPU, TPUs in the future, how we can make the entire process as streamlined as possible. So your data scientists can focus on creating machine learning models rather than worried about infrastructure and managing the infrastructure. At the other side of the thing, we also provide ML machine learning APIs. So these are APIs that exposes Google models that's been used many years in production, whether it's things like speech recognition, that's the same technology that powers OK Google on 1 billion Android phones, or it could be things like image understanding using Vision API that's powered by the same technology under photos and image search. So really taking all the underlying technology that we have in Google, underlying models, trained on Google data, and exposing that as APIs for you to consume. And that's really targeted more as an app developer that says, hey, you know what, for my use case, these machine learning APIs are a good fit. I'm going to use that. I don't need to learn a lot about the ML underneath the scenes. So let's kind of talk about how have we applied these problems on some scenarios. And that's the rest of the session is really thinking about how have we taken these ML techniques and applied that on some of these real-world scenarios, both inside Google and outside Google. I'm going to first focus on unstructured data. Why do I do that? Because there's been a recent study from IDC shows that even though we spend so much time thinking about data in our ERP systems and CRM systems, a lot of the data we have sits in our enterprise content management side or just sitting in file shares. And all we do with that is just consume it. We have no idea about the metadata around that, and there's no way for us to intelligently process that. And that's the first area that I want to focus on. That's really been an area we focused on with a lot of our machine learning APIs. So let's start off with image and video side. Image and video is a great example where people have primarily focused on consumption, but have very little understanding of what the content is about. And that's the first use case I want to talk a little bit about. And I'll start off first talking about how we're doing this inside Google, and then talk about some customers. In this case, there's two aspects. One is how we have applied machine learning for you to search on your favorite niche. We talked a lot about that in photos. But another aspect is also thinking about the production of the content. So in one of the cases in user-generated content is, you can imagine somebody taking a video on their phone. There's a little bit of jar. Your thing is shaking a lot. So what we've done in some aspects and things is we do things like auto-stabilization. We automatically stabilize the frames in the video, and you can imagine in this downhill biking one, the video automatically reduces the jitter and provides a stabilized video out of the box. And that's really about machine learning behind the scenes. Another aspect is how do we detect inappropriate content, right? It's a big problem, especially in organizations that deal with user-generated content. How do we detect things like violence? How do we detect things like adult content? It's a big problem these days on how do we kind of minimize making sure your customers are in a safe environment and not exposed to some of this inappropriate content. And there's a lot of other use cases at Google. You can talk about things, everything from self-driving cars. That's really powered a lot by things like both our radar side and image recognition, and sometimes we're actually running this on device to really enable these cars to do these billions of transactions, calculations as fast as possible. To things like how we enable things around image search. So if you go search for an image, how do we streamline that? To lots of other examples inside Google. But let's spend some time thinking about how our customers have used this today. Let me talk a little bit about this company called Descartes Labs. And what they've been focusing on is, you can imagine around the world, we have tons of satellite imagery taken about across the surface of the Earth, right? And so what can we do with all these geospatial images that all this focus around the Earth? So their problem was, hey, can we use this imagery to derive economic indicators? And one of the indicators they wanted to focus on was food output. As you can imagine, food output is a very crucial statistic that everything from the US Department of Agriculture to most government organizations focus on. And what they looked at was based on the geospatial imagery and other indicators between the altimeter of the crop, etc., they can detect the actual crop output for grain and soy. So it's a very interesting use case where they're actually using geospatial imagery to drive what the output signals are. Another example, this is from Global Fishing Watch, and what we'd focus on here is, you can imagine, over 1 billion people of us use fish as a primary source of protein. But one of the issues we have is 85% of our fisheries are overfished. And what they wanted to detect was, is there a way for us to detect which areas are getting overfished or not? Primarily, before they had a set of manual analysts looking at region by region. As you can imagine, they're an NGO, their budget is limited, and they can't scale. So how do they streamline this process? So one of the things they wanted to do was, can we detect what kind of fishing boats are at what parts of the ocean, so they can then drive an additional ML model to detect the amount of fishery output. So what do they use? Each vessel, fishing vessel out there, broadcasts what's called an AIS signal that shows their latitude, longitude, location. So different boats can use that signal to avoid collisions. So they use that AIS signal to start plotting all the different tracks of these fishing boats. And based on the tracks of these boats, they can then detect what kind of fishing boat it is, whether it's a trawl or a long line, different kind of fishing boats. And then they have an idea of how much fish each boat is going to fish. And based on that, they can predict overfishing or underfishing. Does it make sense? So really thinking about a different use case of how they can use image and geoimagery to drive certain aspects of how fishing impacts our ocean. Other kind of business use cases, and here's a scenario where, we talked about this earlier about Airbus. It's one of the largest organizations in the world. And the problem they've been dealing with is, how do we detect clouds from snow when you look at geospatial imagery? And it's a difficult problem even for us. And the challenge that they wanted to have is, hey, how can we easily figure this issue out using machine learning? The challenge they have is the amount of imagery that goes in that they consume every day you can imagine, grows significant, right? All based on all these geospatial satellites. So what they did was they used deep learning using TensorFlow to start predicting which part of the thing is snow, which part of it is cloudy, and based on that, you can imagine it drives subsequent downstream applications of navigation, etc. And they did that using machine learning and cloud ML. And really, the key use case was that how they reduced both the error rate, and they were able to do it much faster in an iterative manner using some of the cloud machine learning engine platform. Other use case, this is, again, you may be like, why am I showing potato cubes? QPI is one of the largest kind of mayo manufacturer and one of the top raters from a brand safety in Japan. And they work with a partner of ours, BrainPad. But what their problem was that you can imagine, as a food processor, they have potatoes streaming down the food processing pipeline. And before, they used to have a manual person looking at these potatoes to see, hey, is this a defective potato or not? Because you can imagine they don't want defective potatoes to flow into the mayonnaise you consume. You can imagine somebody looking at that pipeline with the eyes glazes over time, and they're going to miss a few. So they use complex imagery to drive images off the pipeline, feed that into an image classifier to understand, hey, is this a defective potato or not, and then take some action based on that. You can imagine this applies, I gave this use case about food, but you think about your manufacturing pipelines, right? is there a way that I can now take photos on my manufacturing pipeline to understand is this a broken part or not, and use based on cameras you have in your manufacturing line to drive information out. Or it can be things around if you're if you're a manufacturer, you have a large facility, you take photos of your facility to start identifying potentially cracks, etc., in your pipelines, in your equipment, etc., and really think about how can you use imagery to drive some of these information signals. Here's another use case. In this case, this is we had a large car auction house in Japan. And their issue is, they have a lot of different people inputting information about cars. And before they had to, for example, you can imagine there were 5 million cars listed on the inventory. For every car, they need to get roughly between 30 images or so, 18 exterior, 12 interior. And for each one, they need to, out of that, they have to derive make, model, the parts, what angles are missing, and it was a manual process to drive the entire process. And they're like, hey, we can, as we think about doubling, tripling our business, this process is not going to scale because we need to do this for every new submission. Can machine learning help us? And that's a scenario where they really use image classification again to drive some of these scenarios for them. So they're thinking about where they can now detect, hey, is this a certain type of car? Is the engine here? Are all the parts that we wanted available in the imagery? And then classify those parts. And you can imagine all the different, instead of a manual person sorting through 30 images, some of the AI aspects helps them in that process. Here's another case where a customer of ours, Wix.com, they have a media platform where they enable folks to build their own websites. And what they wanted to do was, hey, can we easily classify the videos and images that people upload? Right? So it's basically, think about a media platform where there, if you're creating your own portal, your own web page, and you want to upload some video content, and you want your users to be able to search within that video content, how do you enable that? So they use some of Video Intelligence API, use some of Vision stuff to get metadata tags or the video content, and then they can then enable their customers for the search experience. Let me walk through a little bit of demos, because this. The first thing I want to is, let me go back and bring this image back up. So in this case, for example, we automatically pull everything from this. Think of a receipt or an invoice that you may have, and is there a way to digitize a lot of these? So this kind of goes in the paper digitization aspects. And you can imagine if you'd want to pull the total, the tax, etc., and you also want to build things on whether there's any logos available there. Another example would be, for example, here's a case where, based on the image I took today, I was walking through the Tower Gateway to catch I don't think you guys call it underground, but I catch the over-the-ground line to come to Excel. For example, it automatically finds famous landmarks. So these are some of our machine learning APIs that enable some of these things out of the box. Other examples can be things like, hey, in this case, this is a picture I took right on the train station. Can I find where this picture is off? In this case, we find out this is from the Prince Regent DLR station. So basically, how do we use our vision APIs and all these machine learning APIs to get metadata out of the box? So that's another example. Another aspect is, you guys saw the DLP demo that we had as part of the keynote. So this is an example where they use some level of machine learning. So example in this case is, I'm a customer service agent. I'm dealing with a customer, but the customer is giving us too much protected information, like social security number. How do I ensure that I redact this information before I store it in my logs? Right? So because there's all kinds of PII associated with that. This is an example of both classification, text classification, some level of OCR, and you can imagine a business process that brings all these technologies together to ensure that the information is redacted. Other examples are things like video. For example, in this case, hey, I want to find a, let's take an example of an Android phone in this thing, so we automatically can detect the location of all these different items, etc., in your video content. Another example is, hey, how can I find information around, is there any consumer electronics in this? And you can find things like Android phones, etc., out of the box. Other examples are around imagery. So in this case, it's the nature imagery, and it has a lot of different beautiful things around animals, etc. So we use a lot of the video intelligence capabilities to detect all kinds of entities within your video content. So I just walked through a lot of different examples of both. I am not playing, am I? Let me just play that. So as we go through these shots, you can imagine that we're using a lot of different capabilities. We showed a lot of examples of customers creating their own models. We showed some demos of how people can use some of our machine learning APIs to further your own specific use cases and just consume the ML as an API. Now, going back to slides. Now, let's spend some time on the language side. We spent a lot of time on images and video. Machine learning is not all about images and video. So let's talk about some use cases that we have inside Google. For example, we introduced Smart Reply in Inbox, where we basically do classification of the messages that come in, and then we provide some easy responses out of the box. So that's basically a pretty complex way of doing text classification. Then we've also done Google Translate. This is also, in the last year or so, we migrated from using both traditional kind of machine learning models to using more deep learning-based models. And we've seen a significant jump in quality. And this is a new model that we launched in November last year. And then other aspects of language understanding, everything that we're doing around conversation bots, everything we're doing around both API.ai or things around Google Assistant or Google Home is really driven by things around how we enable both language understanding, both whether it's speech recognition, text understanding, and then based on that, taking some action off that, right? By understanding entities, understanding the intent of that message, and then figuring out what to do with that. And the thing I want to talk about is this applies to you also, right? Your customers can reach you in many different ways, whether it's a phone call, whether it's a message, whether it's a Facebook message, whether it's social media, where they're talking to you or they're talking about you. So you want to understand what are they talking about so you can take action on that, right? So it's not just, it doesn't just apply to consumer messaging apps, it applies to you from an enterprise perspective too. So you can figure out what action should I take, what's the sentiment of what's going on about my organization in the outside world. Here's an example that we have a customer of ours who's been using API.ai to drive a set of actions on their scenario. A lot of ways for customers to reach ING. But one thing they've used is, for example, they have a Facebook Messenger bot that they're using through API.ai for customers to engage with them. And then they can then start taking action through that, right? So examples, based on the action, they have a set of intents that they support, and they can start enabling the customer service experience directly where the user is, rather than sending them to some other location. Another example, I think, is, for example, Okada was on stage earlier today talking about things that they do on text classification. That's another example of our focus on customer service, on, hey, as we get emails flowing through, how do we start classifying them? We don't want, the days are gone when we give people a multi-edge form with all these different fields that people need to enter. 9 out of 10 times, people don't use those fields and just enter a bunch of text in the free form, right? So how do we enable people, how do we read that free form text and figure out the structured data out of that? And that's becoming more and more common use case because your customers are doing that in their consumer apps. So they're going to start expecting these enterprise apps to behave the same way. Let me just talk a little bit about going back to demos. In this case, here's what we've done is we've used our natural language API. And you can imagine, we think about the fact that we've gone and scrolled through all of Wikipedia, and we're trying to find all the relevant entities within a block of text. So in this case, we're looking at Doctor Who, a famous TV show, and we go and basically figure out, hey, what are all the top entities that Doctor Who talks about? You can imagine a big part of it is thinking things like TARDIS, the Doctor, aspects of the planet. These are key entities, and you can actually imagine these entities are already in Wikipedia also. Now I want to understand, hey, when I think about TARDIS, what is TARDIS normally associated with? In this case, I want to imagine I build a relationship graph. So in this case, for example, we normally realize that TARDIS is normally associated with Doctor Who. He's British. He's from the planet Earth. They're normally located in London, and it's a show generated by BBC. Now, this is an example I'm using from Wikipedia, but you can imagine that in your world, you want to start building relationship graphs. Who are your top customers? Which organization are they interacted with? What products do they normally flow? If I change one piece of the puzzle, what's my impact on another piece of the puzzle? How does it all flow? And really, a lot of that comes from building relationship graphs, and language understanding can help grow your relationship graph. Another example is around speech understanding. This can go sideways, but I'm going to try it. Andy Murray is a famous tennis player. So in this case, I pick up the fact that Andy Murray is a key entity in this block of text. I also pick up the sentiment on famous, and I realize it's a positive sentiment. So this is an example of using speech recognition to get the transcription out, and then we do some level of language understanding on top of that. Slides? So most of our world is not images and unstructured text. We still have data. The remaining 10% of your data is sitting on your ERP and CRM systems or your own homegrown transactional systems. What do we do? So far, a lot of folks have done rules-based systems. Example is what we've done in search in the earlier part of the decade. Like, for example, when you type Giants, how do we know whether you should search for San Francisco Giants? How do we need to search for the New York Giants? So one is a baseball team, the other is a football team, right? So it's totally different context. We really need to understand the context of what's going on to interpret the right result. And we used to have rules for a lot of these things. So we used to code roles based on user location. We used to drive. You can imagine this rules infrastructure exploded based on the permutations, combinations, user intent, and this is not a scalable way for us to drive that, right? That's really what Eric Schmidt was meaning in the beginning, was that people used to code all of this as rules and heuristics to drive the entire workflow. Now the question was, hey, can machine learning understand these patterns? So you don't have to code a lot of these things out and then basically create a machine learning graph to understand the patterns to drive the user experience. And that's really what we did with RankBrain. It's one of the key, we released a white paper on that earlier in the year, talking about how it's like one of the key signals that we're using for Google search. The other aspect is we're thinking about is data center efficiency. We take a lot of pride in how we reduce energy usage in our data centers. Really, when we think about today, we get 3.5 times more computing power for the same amount of energy from a decade back. And we're always focused on green energy usage for our data centers. But one of the things we want to do is, hey, can we actually think about reducing our data center usage? And that's really where we've worked with AlphaGo to think about, can we apply AlphaGo on our air conditioning units to reduce our data center usage? Really, can AlphaGo learn, can we start reducing the amount of energy spent on air conditioning based on all the different factors that happens inside the data center? And one of the things that we did was, when we turned it on, we actually reduced our overall data center usage by 40%. And you can imagine for the amount of scale of energy that we use across all our data centers, this is a pretty significant benefit we got from an energy usage perspective. So let's talk about your scenarios and about how customers are dealing with that, right? We have a lot of different solutions for structured data. They can sit everything from your data warehouse sitting in BigQuery to your transactional systems. How do we deal with that? Lots of different use cases. It's a ISO chart. You guys have more of use cases that you yourself think about. But let's talk about some scenarios. In this case of AXA, they're a large insurance company, and their use case was, hey, how do I think about, from an actuarial perspective, predicting what the premium should look like? So as you can imagine, the problem is a few customers cause lots of accidents, and how do we ensure that the premiums are not, we're not overcharging the appropriate customer, right? So a common problem being for our scenario, how do we think about fraud and abuse, and thinking about, and you want to account for fraud and abuse, but you want to make sure that we're not charging other customers too much because of these fraudulent customers. So really, that's why if you can use ML to predict that these set of customers are potentially fraudulent or high cost, and you can then do more rational pricing where you can price different things differently for the customer based on what their profile is. Another example is about, I think I spent a lot of time on fraud today, but you can imagine, this is another example of how we're shifting from a rules-based system to an ML system. In this scenario is a bank. They worked with a partner of ours to drive this scenario, where they're really thinking about, they had a lot of manual rules in their organization to drive whether someone is fraudulent or not. As you can imagine, customer dynamics, things change every day. Those rules are going to get outdated every day or every hour, right? Because there's so much change happening in the overall environment. And how is the environment going to learn from that? Otherwise, you're either going to constantly be programming, or you can let ML start learning these new patterns. And that's kind of what they did. They started driving more and more of these transactions through their machine learning models. The models start learning these new patterns of data, and they then feed that through their approval results, and they get faster turnaround. So that's really one of the takeaways you're thinking about, is how do we start moving some of these heuristics, rules-based systems to thinking about ML-based systems, where letting the system learn from the data rather than you hard coding rules. So that's one. If I think of another takeaway, one is data is the key to everything. The other takeaway I would want you to take away from this is how do I think about moving from rules-based systems to ML-based systems. So this is really what I end with, really thinking about. It all starts with your data. You got to, ML doesn't work without data, right? It's got to start with your data somewhere, and then you want to drive a set of models. There's some models that you build yourself. There's some models that we can help you with our machine learning APIs, and then you start taking action on the insights that come out of that. We have a lot of examples. We have examples for things that on unstructured data where our ML APIs can help, and there are things that you want to do with Cloud Machine Learning Engine and TensorFlow for your own structured data, or a lot of scenarios that's very unique to your business. And what I want you to take out of this is how can ML change your business, right? Think about how it changes your user experience. How can your apps be different with ML, right? For photos, all they changed was the search experience, right? And think about how people love photos, because all of a sudden, people have just stopped tagging. People hate tagging. They want to say, hey, can you guys figure this stuff out, right? Your users want you to figure stuff out from the data they provide. Therefore, that's a user experience problem. The other aspect is how do we think about your business processes? Think about scenarios that's kind of today. How is that going to scale when your business grows 2 or 3x over the next 5 years? How can you think about streamlining your processes, and how can we learn patterns from it to help you scale? And the third aspect is how do we enable new scenarios, right? How do we think about intents and actions that you want to enable in your business for scenarios that you're going to think about, right? For example, if you're thinking about advertising, how do we drive more relevant ads based on the content rather than just saying, here's a 30-minute slot, I'm going to put 5 ads here, right? How do I start providing relevant information to the right user at the right time? So that's really what I want to talk to you guys about. I hope this was useful. And we have 5 minutes for Q&A. I think we have folks with mics you guys can ask questions to. While questions are coming up, there's a set of related sessions that I would encourage. Go ahead. I don't see a mic anywhere. Front. While we get the mics, there's a bunch of related sessions for you guys. Tomorrow, there's going to be Martin Goner is going to talk about deep learning with TensorFlow. We also have machine learning APIs with Sarah in the afternoon, and I'm also going to be talking about ML on retail.
Hi. We've recently done some testing on the Cloud Vision API for image recognition. Wanted to get your thoughts on what the machine learning curve is.
Yeah.
And do you start with a completely blank slate model, or do you take what the API already knows and then teach it to speak the language of that organization or that integration? Do you have to start from scratch every time you implement a new model?
Yeah. I think there are different ways. One is if there is a domain that our machine learning APIs know out of the box, for example, in consumer and media, we can use the APIs to get some level of labels or metadata out of the images, and then maybe translate that to what the organization understands. Another example, there are unique tags that's specific for that organization that, for example, Google may not know. Right? That's something very relevant to the thing. For example, if it's a furniture store, they want to understand this specific type of furniture, right? That Google will never go there. That other aspect of doing that is there are things like transfer learning that's becoming more and more prevalent, especially in the scenario around images, where you can take an existing model and train an additional set where you can get specific images for that tag, roughly around 1,000 images or so for that tag, and you can build a new model that's relevant for that single entity. Does it make sense? So there are examples of that on both TensorFlow and on Cloud Machine Learning Engine that allows you to basically say, hey, there's already an existing model like Inception. I'm going to basically take that and bootstrap it for a thing. But for scenarios that, for example, Cloud Vision understands, some of the things that Cloud Vision may be a better fit. And the things that we introduced with things like web detection, the metadata grows a lot more, especially for images that's similar to available on the web. Other questions?
Sorry, may I have another question relating to my colleague who just asked? It's over here.
Yeah.
So you did mention that the client can train their data using their own model. is there any minimum business requirement in terms of the volume of the data or the variety of the
Yeah,
data?
I would say if you're thinking of transfer learning to entities that's available in the Inception V3 model, which is really about real-world entities like plants, animals, transportation, normal word of mouth is in the order of hundreds to maybe potentially low single-digit thousands of images per tag, and then you should be able to come up with your own model for that specific entity. But there are also other examples, so that's a good way, that's a kind of a heuristic to think about of number of images needed per tag. Go ahead. You can shout it out if you want.
Machine learning tends to favor those who have access to big piles of free data, and you said yourself that is Google's differentiator in the marketplace.
Yep.
How do you think the market for machine learning will change with the trend towards decentralization and blockchain, where people have more control over their data and data will begin to be priced more rationally than it is now? How will that affect the market?
I think, in some ways, you can imagine over time there's going to be growth more and more of what I call these APIs for targeted scenarios, right? So where, right now the APIs that we have are more focused on general structured data stuff. But over time, there's going to be scenarios where people have, based on certain data sets they own, they can now offer, before people used to have data set exchanges, but you can imagine this becomes more and more of a model marketplace where they offer these models based on data they own, and they offer inference on that. So and that's, you can imagine natural evolution of that over time.
Yeah, hi. I'm just wondering whether Google ever intends to basically open source the weight as opposed to just using the API so you can actually use the pre-trained data more locally.
Yeah. There are some aspects that we've already done. If you use TensorFlow, the Inception model is actually open source, which is the base image classifier. So there we've actually open sourced the weights. We also open source a bunch of things around the YouTube 8 million minutes classifier, which has both video features and vision. We didn't necessarily classify the weights, but we actually open sourced the data. And we also have a Kaggle competition where we're actually encouraging everybody to contribute what we think the most optimized model is. And you can imagine over time we'd open source that also. So really, in some aspects, we're already going down the path of open sourcing some of the weights for some of these classifiers. Clearly, some of our production models that we fuel through Vision API and stuff will be provided only through the API. But there are other aspects where we definitely start open sourcing some of these underlying weights. Yeah, I would definitely, if you guys, keep in mind, like, if you guys go to TensorFlow.org, there's a lot of, on the open source side, there's a lot of different examples of how people, both within Google and the community is open sourcing a lot of different, some of these pre-canned models and scenarios. Other questions? And I'm going to get kicked out after this. Go ahead.
OK, yeah. Hi, question for you. I know Amazon is offering things like FPGA services.
Yeah.
Does Google intend to do the same with its tensor processing units for specific tasks?
It's definitely top of mind for us. I think what I would say is stay tuned for more news on that aspect of that. Because we've already announced, at last I/O, we already talked about tensor processing units, but we're definitely something we're looking at. That's it, guys. Otherwise, my Twitter handle is there. Feel free to ping me with questions. I would love to hear from you guys. Thank you.